Good afternoon, and thank you for joining today's webinar on data visualization best practices. My name is Karen Rajat. I'm the Analytics Marketing Director, and presenting today will be Eric Tobias, our Vice President of Analytics Services. Just before we get started, I want to tell you a little bit about Analytics. For those of you who are not familiar with our company, we've been in the business intelligence and analytics space since 2001. Our primary focus has been on Tableau for the past 7 years. We're both a premier Tableau reseller and a certified service provider. We offer a full range of Tableau services such as dashboard creation, Tableau training, data preparation, which includes ETL and data warehouse solutions, as well as Tableau server implementation and governance. We have extensive Tableau expertise. We have completed over 350 Tableau engagements. More than 1,200 Tableau dashboards have been built by our expert consultants, and we have trained over 2,800 users, Tableau users, sorry. Analytics has over 900 customers, and as you can see from the sample of logos here, they're from a broad range of industries and job functions. At Analytics, we help our clients extract meaning from their data so they can confidently make business decisions based on knowledge. So I hope you know a little bit about Analytics now, who we are and what we do. I just have a couple of more items before we get started. There will be a Q&A at the end of the webinar. You can just type your questions in the control panel, which you'll find in the top right of your screen. And there will be a recording of the webinar following today's presentation. So I will now pass things to Eric, who will give you his insights on data visualization best practices.
Hello, everybody. As Karen mentioned, I'm Eric Tobias, and I am going to be going over the webinar today, Visualization Best Practices. Before we begin, there's a couple of things to make sure everybody knows what we're talking about, set a baseline here. What is analytical visuals? Well, according to Stephen Few, who's one of the original data visualization evangelists, a visual is a visual display of the most important information needed to achieve one or more objectives, consolidated and arranged on a single screen so the information can be monitored at a glance. There's a lot there, but essentially what we're trying to say there is you need to have the most important information presented appropriately so that it can be intuitively understood. And we're going to talk about what intuitive means from visual best practices perspective. So what we actually are going to be discussing is the application of visual and cognitive neuroscience to building your dashboards. How does that apply? There's a whole lot of science that's gone into the neuroscience behind how people process visual information, and we're going to discuss that a little bit here. What we first need to determine is we need to determine what the difference is between perception and cognition. There's actually a very big difference between those, and in terms of how the human brain works, it's very important to understand the difference between those. So we're going to go over this in a little bit, give you some of the why this is important, and then we're going to show you how to apply that within a dashboard. So to start off with, perception, the technical definition of perception is that it's the organization, identification, and interpretation of stimuli from your senses, specifically in this case the visual sense. An overly simplified way is to describe it as acquiring information through your senses, or in this case, your eyes. Cognition, on the other hand, is the process of information and processing of information and acquiring knowledge through reason, intuition, and perception. So that's a technical definition. What we really mean, a simpler way, is it's the processing of perception and turning that into knowledge. The main difference between those is perception is very, very fast. Cognition is very, very slow. So if you can take advantage of perception, you can actually make your visuals work much more intuitively with your end users. So that's what we're going to say here. The more you can take advantage of visual perception principles and design around those principles, you will have people that understand your visuals much faster and much more directly without having to try and interpret things. And that's what we essentially say. When somebody says there's an intuitive visual, what they really mean is they really mean that it's a visual that properly implemented visual best practices and the science behind it. So cumulatively, we call those visual best practices, or VBP, in the slides that will follow. So let's take a look at a couple of examples here. And you should be able to fairly easily tell which ones correctly implement visual best practices and which ones do not. So here's an example of a dashboard. And I'm going to show you two dashboards. They're both made from the exact same data. They're both made with the exact same application. In this case, it's Tableau software. It's just that one of them properly implements visual best practices and one does not. So here's one of the versions of the dashboard. I'm not going to go into detail about it. It should be pretty obvious what we're talking about. And there is one that implements the same information, same software, but uses visual best practices. The one on the left, much harder to read than the one on the right, which is much more clear, and you can get the information that you need very, very quickly. Let's take a look at another example. So here's a visual. It's a set of data, and we're going to look at an equivalent one, exact same data, exact same software, but implements visual best practices. So hopefully what you're able to see there is that when you employ visual best practices, the dashboards that you end up creating are much more readily interpretable or intuitive. So what we're going to talk about now, that's to show you how that applies when you're actually constructing these visuals. We're actually going to talk about how you can take those and essentially hack the human brain. And what we mean by that is take advantage of perception and get your users to understand your visuals much more quickly. Something to keep in mind, seeing, which is perception, and comprehending, which is cognition, occur all the time, every day, from second to second. As long as you're awake and your eyes are open, you are perceiving and cognition is occurring. The shorter the time between seeing and comprehending, the more productive your end users will be. If they look at confusing content that isn't easily understood, it takes them a lot longer to take a look at that and to get what you want them to get out of it. Those dashboards will be considered intuitive if you properly take this into account. Above all, what we're talking about are scientific principles. This isn't just myself or somebody else at Analytics that's put all of these together. This is actually from years or even decades of science that's gone into this neuroscience, visual and cognitive neuroscience, PET scans and MRIs and functional MRIs and blood flow monitoring, and all of that has gone into thoroughly understanding how the human brain processes this visual information. First thing we're going to make sure you understand is exactly what we mean when we talk about perceiving happening very, very quickly. The amount of time we're talking about is very short. And in fact, there's this part of the human brain called visual short-term memory, or usually abbreviated VSTM. It can process very small amounts of information, but it can do it very, very fast. And when we say fast, we mean really, really fast, to the tune of 40 milliseconds. So when somebody's looking at a visual, they're going to spend about 40 milliseconds on each element of your visual trying to put your story together that you're trying to tell with your dashboard. So if you have confusing content that takes them 1 or 2 seconds in order to understand that, then that's going to start requiring additional processing and everything's going to slow down. Even the stuff that you did well is going to start slowing down. So what we want to do is we want to take advantage of visual short-term memory, and we want to know what works and what doesn't work when you're talking about visual short-term memory. Things that work well with VSTM are called pre-attentive visual features. These are well defined, and we're going to go over a list of those in just a couple of slides so you'll understand what we're talking about. Pre-attentive visual features take advantage of visual short-term memory and perception and occur in the tune, like I mentioned before, of about 40 milliseconds, so very, very fast. If you don't take advantage of visual short-term memory, you will end up requiring much more robust processing. It has to be done in a different area of the brain, and it is much, much slower. If you'd like a little proof of that, I have a couple of examples I'll show you. So I'm going to do two things. I'm going to display some information for you, and you'll have to try and understand what we're looking at. And then I'm going to apply visual pre-attentive features to it, and it'll make it much, much more understandable. So I'm going to show you a sequence of numbers, and you should be able to figure out how many 5s there are in the sequence of numbers. I'm not going to wait too long because it takes way too long to be able to figure that out. But as you can see, this is not implementing pre-attentive visual features very well. That has to be done attentively. And in fact, we actually have to process those sequentially, starting from the top left, going to the bottom right, looking at hundreds and hundreds of numbers to try and go find all those 5s. This is being done cognitively and takes a lot longer than it should. And in fact, we're actually processing this using our linguistic skills by finding those number 5s, or we're using it using pattern matching skills by finding things that are shaped like a 5 is shaped. Either one of those require cognitive processing and are very, very slow. So instead, I'm going to make one little change to all those numbers, and let's see if you can find how many there are much faster. So it should be pretty easy to see that there are 6 5s in there. The only thing we did there, now this can be done pre-attentively, and we did that by using the pre-attentive feature called color hue. Color hue is a different color applied within the same set of information. So by applying color hue in there, we are able to pre-attentively process that, and it's orders of magnitude faster than trying to do it the prior way. This technique is known as perceptual pop-out, and a lot of the tools that you'll see out there implement that using something called a highlight feature. In Tableau, there's highlighters, there's highlight actions. Those all use color hue and pre-attentive features to get the information to be more readily processed. Let's take another example. I'm going to give you some information, and what we want to know is we want to know if our sales have increased or decreased over a 4-year period. And indeed, we want to know of the categories that are displayed, which one is growing the fastest. So this is even worse because now we have to not just look at numbers, but now we have to do math as well. So this is even slower for us to try and process. This should also highlight the drawback of using crosstabs or text tables in your visuals. It's the slowest possible way for a person to understand the meaning of the data that they're looking at. This cannot be processed pre-attentively. Both linguistic and mathematical skills are required to process that, and that's very, very slow. So I'm going to take the exact same information, and I'm going to apply visual best practices to it, and the same questions. Have the sales gone up or not? And which category has gone the fastest, grown the fastest? And that you should be able to process very quickly. In fact, I should be able to put that up on the screen for about 40 milliseconds and take it away, and you would still be able to figure out that one of the lines was ahead of the others and they all were generally going upwards. That's using pre-attentive features. In this case, we're using color and position. So what do we mean when we talk about these visual features? There's a list of them. I will give you the list and I will give you examples of them. When we talk about pre-attentive processing, there's the form of data: line orientation, line length, line width, size, enclosure, shape, curvature, concavity, convexity. That's the form of a visual. There's color. Note there's only 2 things with color. One of the most overutilized features in all visualization tools is color. There's only 2 approaches to color that are pre-attentive. One is hue, the other is intensity. Hue would be different colors like blue and orange. Intensity would be different shades of the same color, for example, light blues and dark blues. When it comes to position, there's a couple of things. There's 2D position, stereoscopic depth, motion. There's flicker, direction of motion, and velocity. So that gives you kind of an idea of what the final list is, but I'll actually show you an example of each one of these. So line orientation, for example, as soon as this flashed up, your brain immediately went to the top left there and saw that slightly diagonally oriented line. because it's different than everything around that. So your brain is hardwired to notice that because the orientation of that line is different than the others. So that's a pre-attentive feature. We have a number of slides I'm going to show you, but I'm going to go through these a little bit more quickly because they're just examples of each one of these. I won't go into as much detail on each one. We have line length or width down there on the bottom right. There's one that's longer than the others. We have size. There's one kind of in the bottom left that's a little bit wider than the rest of them. Enclosure, those 6 bars over there were all immediately brought to your attention because they were enclosed by something. Shape, you'll notice of all of those corner L-shaped ones, there's a plus there. So your brain immediately went there. We have curvature, kind of on the left-hand side. Concavity, convexity, we can tell which ones are down and which ones are up. Color hue, that's different colors. Color intensity, top right, we have the lighter blue color, so it's the same color, just lighter or darker version of it. 2D position, in this case, the one on the bottom there is out of position and draws attention. Stereoscopic depth, one of the things to not be thinking of when you look at this is 3-dimensional. I will tell you that anything that is 3-dimensional automatically requires cognitive processing. It cannot be processed pre-attentively, must be processed cognitively. So for example, if you're in Excel and you go and you create a 3-dimensional bar chart, which is very easy to do, you've automatically forced your users to process the information much more slowly than they need to. What stereoscopic depth is, if you notice there, it looks like it's 3-dimensional, but it's not really. Stereoscopic depth simply means we can tell what's in front of or in back of something else. So we can see that that darker shaded circle is in front of the lighter gray circle that's behind it. So stereoscopic depth is only what's in front of or behind something. It's not 3-dimensional. We then have flicker. Your eyes are attracted to the things that are moving or changing. We have direction of motion. When things aren't uniform, direction of motion is pre-attentive. And lastly, velocity. We can see that some things are moving faster than other things. So everything I just showed you are all of the pre-attentive features. I will tell you that there are obviously lots and lots of scientists that study this at all times. Some scientists say that some things should be included in this list, and others say that some things should not be included in this list. But the ones that are in this list are the ones that are most generally agreed on. So we've given you the visual features. There's 2 things you need to know in order to properly use these. You need to know what the visual features are, which we just went through, and you need to know what type of data you're working with. Once you know those 2 things, you can properly put these together. We'll then show you how to combine these together. So the next thing is the types of data. There are 3 types of data. There's categorical data, which is data that logically belongs to a group based on some characteristic. So for example, if I say North America, Europe, and Asia, I'm sure you're able to sit there and say, oh, those are all continents. They're all continents because we recognize them and they categorically belong to each other. Eric, Sherry, and John, those are first names of people. You don't even know who they are, but you're able to tell fairly quickly, categorically, that those are names. And pizza, Twinkies, and potato chips, in case anybody missed your lunch. So there's some junk food in there, all grouped together because they have common characteristic to them. Then we have ordinal data. Ordinal data is similar to categorical data with one exception. It belongs in a specific sequence in order for it to make sense. So for example, at the Olympics, there's gold, silver, and bronze medals. When it comes to education, there's doctoral, master's, and bachelor's degrees. If you put those in a different order, people will get it, but it'll take them an extra moment or 2 to understand what you're doing. Probably the most famous of ordinal data is time. So May, June, July. If I were to display the information as July, May, June, that's going to do nothing but confuse people. So ordinal data needs to belong in a specific sequence for it to be intuitive. The last type of data is quantitative data that defines how much of something there is. For example, sales of $10,000, $1 million, $4 billion, when we look at that, we can see the order of magnitude difference between those because it's quantitative data. Or SAT scores, or fertility rates, or temperatures. All of those define how much of something. All right, so now we need to put those two things together. So we have the visual features that you can use. We know what the types of data are. So the final information that you need is how to combine those. So this table right here shows you the most effective way, based on empirical science and research, how to apply the visual features based on the type of data that you're working with. The most effective visual feature is listed at the top, and they decrease in effectiveness as you go down. One of the things you should probably notice is that regardless of what type of data you're working with, the #1 most effective way to pre-attentively display that is going to be using position. That's going to be your X and Y axis. That's going to be your rows and columns, whatever label you want to give it, but that is position. And then, for example, if you're working with categorical data, the next most effective way would be using different hues. So that would be, for example, your categorical color palette. That would be the next most effective way to do that. However, if your data is quantitative, the next most effective thing after position is to use length. So this gives you and length for, in this case, for example, would be bars. So if you have a bar chart, the most effective way to visually display quantitative data would be to use bars that are longer than each other. So hopefully you can see the result of a whole lot of science, and this should be fairly intuitive for you to make sense. At least on my team, I make sure everybody memorizes this list so that you know how to properly implement everything that we've talked about. You'll notice that only 5 out of the, I think it's 20 or so visual features are listed, and that's because the best visuals don't need more than about 4 or 5 of these features. There's no reason you should need, if your visual needs all 20 visual features in it, it's way too complex to begin with, and you shouldn't be trying to do that. The visual best practice is to have visuals that are as simple as possible, and in which case then you should generally only need 4 or 5 visual features at any given time. All right, so that was all the science behind visual features, but visual features is only one of the list of visual best practices. So now I'm going to show you where visual features fits in with the rest of the visual best practices that you need to know. So the rest of this list is non-scientific in nature, but you need to include all of the visual best practices along with the visual features we talked about earlier. So the consolidated list of visual best practices, the #1, follow a methodology. 2, define the central question. Know the audience. Determine next steps. Classify the deliverable. Profile the data. And here we get into what we just talked about. Apply the most effective visual feature and design iteratively. So I'll actually describe what these mean. Following a methodology is a process by which you obtain your requirements, access the data, design the visuals, and then release those visuals and promote them to your users. Make sure you use a methodology. Within Analytics, we actually have a checklist that all of our dashboard designers are required to follow. If you follow a methodology, you'll be able to get better and better at it over time and achieve consistent quality and continuously improve. And like I said, checklists, very helpful. At Analytics, our methodology is called UD3, Analytics Dashboard Design Methodology, and all of our projects are required to use that. The next visual best practice, define the central question. What question should the dashboard answer? If you have a dashboard that answers multiple questions, what you're going to end up doing is making it confusing for numerous other people. So if you have person A and person B looking at it and they each have a question that's on that dashboard, they're going to be confused by the thing that they're not interested in. So always define that central question. Know who your audience is and how they would clearly interpret that visual. Remember that they're not the designer of the dashboard, so you have to impart all of the information required through the visual. If you don't know the question you're trying to answer, how can you possibly answer it with your visual? Another point about the central question is your question shouldn't be a paragraph. If I ask you, what is the question your dashboard answers, and you have to give me an entire paragraph, it isn't simple enough yet. Most dashboards should be able to have a question related to them that's only 1 or 2 sentences. You can ask corollary questions. For example, if you wanted to say, is there a correlation between life expectancy and fertility rate? That's a good question. If you wanted to say, And does that correlation hold true based on income level? That second question is totally acceptable because it's related to the first question. But you wouldn't want to have multiple different varied questions on the same dashboard. Next, visual best practice, know who the audience is. Not all of your users are the same. They aren't going to have the same level of analytical expertise. Some are going to know what regressions are. Some are going to know what clustering is. Others are not. Not all of your end users are going to be familiar with the subject matter like you are. They're not going to know, for example, when you talk about profit, whether you mean an overall profit or a profit that's gross margin, related to the gross margin, or a profit that's related to the fully burdened based on cost overhead and allocated costs. Profit means a lot of different things to a lot of different people. It's highly unlikely or even desirable that you can answer every single end user's question using the same visual. In fact, I don't think I've ever seen one that is able to be done like that. Are they technical or not? Do they understand statistics? How are they going to access your visuals? Is it going to be on a computer, on a mobile device? All of that you need to know about your audience before you even start building a dashboard. Next steps. Sometimes in a visual, you're going to provide information that is very useful for people to go do something else. And so they're going to need to know, you should define, okay, now that I know that my products are not profitable, I need to go try and fix it. So what are the next steps your end users are going to take? Some dashboards may be information only, in which case there is no next step. And if that's the case, that's totally fine. But if your dashboard is designed to support further action, you should know what they're expected to do before they go perform that action. You need to provide the information necessary for them to do their job. As often as possible, those next steps, that data should be succinctly summarized in as small a location as possible. If you can create a summary table that lists exactly what they need to know to go do their job, you'll do much better, and they will too. Keep in mind there's 3 types of dashboards for analytical purposes. You need to know which one you're trying to design before you even get started. At Analytics, all of our dashboards have to be classified before you even start sitting down and accessing data. Are you creating a strategic or executive dashboard where you answer a very simple question, a very regular fashion, usually on a recurring basis? Is it an operational dashboard where you need to know up-to-date, timely information or exceptional information? It usually has a very simple question or line of inquiry, and it's answered a very specific, very routine way. And the third type is analytical dashboards that provide a variety of different ways to go grab the information they need. So we answer one question, but we give you 4 or 5 ways to go get that answer. That's an analytical dashboard. They're usually much more involved and require a lot more understanding. So you don't usually give those out to people that don't have time to go and investigate them. The next visual best practice, profile your data. Remember what we talked about earlier. The data that you're working with, you should know before you get started, am I working with categorical data, ordinal data, or quantitative data? Make sure you know that before you start designing. Otherwise, you won't properly implement the most effective visual features. Keep in mind, here's the matrix. Type of data across the top, most effective visual features in decreasing effectiveness going along. And lastly, don't wait until you have 100% of all your requirements. Remember that you're taking visualizations from one person to another. And so you need to make sure that both the people that are going to use it and the people that are creating it understand the same thing. The best way to do that is to have check-ins. So at 25% done, you show it to your stakeholders and get feedback. At 50%, at 75%, don't wait until you're done and then go to the user and say, I'm all complete. And then they look at it and say, that doesn't look anything like I imagined it. That allows you to correct midstream and not have to redo a whole bunch of work. Remember, you're communicating visually, not linguistically. So going to somebody and having them just describe what they're talking about is not going to be adequate because your result is going to be visual. So you need to make sure you're seeing the same thing in each other's head. So that's the list. There are 8 visual best practices. Follow a methodology to find the central question, know the audience, determine next steps, classify the deliverable, profile the data, use the most effective visual features, and design iteratively. Thank you.